we're now recording. But yeah, let us go into spectral indices quick start. Thank you for the reminder, Kat. So, spectral indices are combinations of spectral reflectance from two or more wavelengths that indicate the relative abundance of features of interest. And so this is from the L3 Harris docs, which is the creator of the NV software that I believe you all used last semester. You can see on the left of my screen, I have a red, green, blue image, and then a spectral index map, which is kind of this non-specific spectral index that's been calculated, but you can see how certain features are being highlighted as compared to the RGB image. And there's this kind of semi-arbitrary scale from -1 to 1 that kind of describes what's going on in the image. And so if we kind of look at another definition of spectral indices, this one from Esri, the images emphasize a specific phenomenon that is present while mitigating other factors that degrade the effects of the image. For instance, a vegetation index will show healthy vegetation as bright in the index image, while unhealthy vegetation has lower values and barren terrain is dark. So that's just one example of an index that you could create, kind of this generic non-specific index to look at vegetation. There might be another index to look at built up surfaces or snow, just kind of depending on your study area and the questions that you care about. But indices, which is just the plural of index, they're just these tools used to try to monitor phenomenon and make calculations of it. It's kind of hard to track certain things on the ground, and so remote sensing really opens up the world of data collection, especially on a repeat cycle. And so if we're able to generate these kind of indices that are at least relatively tied to phenomena of interest, then it's a super powerful kind of scientific tool for asking questions or answering questions. And so there's many different applications of spectral indices. On the left, you can see an image I got from ResearchGate, which is a website that has lots of academic articles across multiple topics, but this one's specific to remote sensing. And so we see the normalized difference built up index, which is an index used to kind of monitor the extent and I guess intensity of built urban environments across a landscape. And so this is totally different from vegetation, but you can see how you can, or one can create indices to investigate different phenomena of interest. And so on the left in A, it's kind of the tie-dye color ramp showing the entire range of NDVI values. And then on the right, which is kind of more of a binary map that's been created to display the built up versus non-built up environment. And you can see there's kind of overlap in the geometries, but it's just a different way of presenting the data. And so some common applications of these indices are vegetation photosynthetic activity, something like NDVI or different kind of more modern improvements on that index. You can also measure the different phases of water, whether that's like liquid water, snow, ice. I believe there's even some ways to monitor the vapor phase. And so that's a really important application of remote sensing. And then what I mentioned previously, the impervious surface extent, using something like the normalized difference built up index. So today we're going to be predominantly focusing on the remote sensing of burns. And I just want to highlight with this slide, there isn't like just one way to monitor this with remote sensing data. If you think about the kind of Southern California landscape, it's a little shrubbier, drier. Doesn't really look like that image that I'm showing here on the left, but this is from Montana, which is going to be the site of our lab today. And so it's a little more forested, but fire still happens. And so I think depending on where you are, the sensor that you're leveraging, um, the extent of the fire and vegetation, and maybe how close it is to different types of landscapes, can really impact which index you use. And so today we're going to be using the NBR, normalized burn ratio, which is predominantly for larger fire zones, like 500 acres or more. And so not all fires are necessarily that size, but many are much, much larger. And so I believe the NBR index was developed with Landsat 4 through 7 initially, and then it's been kind of updated or it's slightly tweaked to be applied with the newer Landsat family of satellites. And so depending on which sensor you're using, you'll need to leverage a different band just because of how the sensors have changed through time. But the whole kind of flow of using NBR in analysis is you have a pre-fire image and a post-fire image, and you create these NBR indices for the pre and post-fire date, and then you calculate the difference between those, and that's kind of your indication of burn severity. And so that's really what we're going to do today in our lab at a very high level. It's calculating a pre-NBR, a pre-fire normalized burn ratio index, a post-fire normalized burn ratio index, and then calculating the difference to visualize the extent of burned area. We're not going to do anything like trying to calculate intensity or total acreage, but that's something you could do if you were interested in flexing your Python muscles and just learning more, but that's really not required at all. And so, like I alluded to previously, the normalized burn ratio was initially developed for use with Landsat Thematic Mapper and Enhanced Thematic Mapper bands 4 through 7, or 4 and 7, but it'll work with any near-infrared band between 0.76 and 0.9 micrometers, and a shortwave infrared band between 2.08 and 2.35 micrometers. So this image on the left, I believe, is from Sacramento. Yeah. And this left image is kind of this false color composite using bands 6, 5, and 4, showing the surface reflectance from August or from October 2018. And then on the right hand side, you can see the derived normalized burn ratio index for the same area. It's kind of visualizing certain areas more darkly, which I believe indicate fire or burn. So that's kind of our high level explanation of NBR. And part 2 of lab will kind of give you an opportunity to read up more on the, I guess, creation of this index, excuse me, and some of the more scientific, I guess, underpinnings that make this legit. And so I'm really excited to have a discussion with you all next week about, maybe not next week, I don't know if we have class, but whenever we have class again, we'll have a brief discussion about some of these slides or some of these articles. So I think that'll be really fun. And so now that we've kind of gone through these brief slides, I'm going to pivot to the lab. And so we can always come back here later for the open Q&A, but also I've included links to some of the docs that I've been referencing and even some other resources that you might find useful as you're either working through this lab or reading through the articles that I've assigned, just to kind of give you some more context. But I'm gonna pivot over to the lab. So today we're going to be calculating NBR, but we're going to be using some free and open source GIS tools. And these are going to be kind of command line and Python based tools. So there's no user interface like something like Envy or ArcGIS Pro. Uh, I believe you all have some experience using ArcPy. So we're not using ArcPy, but we're going to be using a little bit of Python. So uh, I don't think that this is going to be anything that you're not at least you haven't at least seen before or semi familiar with. And if anything is just wildly confusing, don't hesitate to yell out and tell me. So I see Iris, you have a question. So feel
Yeah.
free.
Did you start recording? Because it's not showing that you are.
Yeah, I'm recording on my computer. I'm not using Zoom to
Yeah.
record.
Okay, I see.
Yeah, yeah. But
Thank you.
I will share the recording after class whenever it's like done uploading. But I'll email you all with the recording. And it should be better. The resolution on my recording should not be blurry. I'm not sure why that's happening, but sorry about that. But yeah, today's tutorial we're going to be using uh, Python inside of Google Drive. And so I think that one of the big pain points for learning a new tool is having to install it on your own computer. And so I'm just going to try to avoid that today. And so the nice people at Google have this free, I guess, other part of Google Drive that lets you run Python code inside of Google Drive. Kind of like you can write text documents inside of Docs or create spreadsheets inside of Sheets. And so we're going to be using Google Collaboratory to create or to run this Python code. And so you see at the top of my screen, it has this open in collab kind of button. And so this is where I'd encourage you all to, you don't have to do it yet because I'd say it might be worth it to just watch for now, unless you feel confident. But yeah, it's up to you. And so we're going to open this in Collaboratory. And so this is really just redirecting me to Google Drive and to this Python development environment inside of Google Drive. I have some silly presets on my interface to show like crabs and corgis. If you don't have to do that, it makes me smile. I don't actually remember. Oh yeah, it's edit notebook settings. No, it's not. Where is it? There's somewhere where you can change it. It's probably this. Yeah, miscellaneous. I'll turn off power mode just because that can be annoying. But yeah, if you want corgis and kitties and crabs, just go here. So I'm going to say you'll need a Google account for this lab. I expect many of you to have one, if not all. But if you don't, it should take like a minute or two to create it. But yeah, and so this lab is heavily inspired by an Esri Learn lab where they use ArcGIS Pro to create NBR for Montana data. And so we're essentially using the Montana data and then reproducing the analysis as similar as possible using free and open source Python tools. So to start, we're going to install something called DTRX, which is short for do the right extraction. And so I think many of you are familiar with downloading a zip file or a .tar.gz file, and then it's annoying remembering which software utility to use to open it or extract it. I think this is less of an issue if you're using a user interface, but if you're doing this programmatically, you can get errors depending on which one you're using. So DTRX is kind of this helper utility that takes that problem out of your hands and just does it magically. So we're going to install DTRX. And we're using pip which is the Python package installer. And we're also preceding these commands with an exclamation point, because that's kind of this weird shortcut to tell Google Colab that this isn't actual Python code. This is more like a command line instruction that I want to run outside of Python. And so we have DTRX installed, which is awesome. Now we're going to be able to extract the data that we want. And so I think many of you are probably familiar with more traditional downloading methods using like your user interface where you click a link, maybe save as, whatever. But you can also do this using a single line script, which is super nice, especially when you have to download a bunch of stuff, or it's just this common workflow you do and you just want to avoid opening Chrome and visiting a website. And so,
Professor, I had a question.
yeah,
Sorry.
go for it.
For us to like, let's say, go about this with you, should we create our own, like, don't open this in Collab, but should we copy paste this into our own GitHub interface and go along with you and download these things, or open it up on our own Python interface? What's the best way to go about this with you?
I mean, I would say open it in Collab. I mean, I'd recommend maybe doing it after and just kind of watching for now. But like, if you click that open in Collab button, it'll open in your Google Drive and it'll be your own copy. And so,
I was worried it would affect your stuff too.
Oh no, it won't. Yeah, as long as you open it in, it'll just reopen. Sorry, I didn't make that clear. But yeah, it won't affect my code. It'll just create your own copy and then you can tweak it. And there's a couple instances where I ask you to kind of slightly tweak it. And so you'll see below as we work through it. Yeah. But thanks. That's a really good question. So thanks.
Well, and then the deliverable at the end, it'll be like that copy that we create. Would that work as the deliverable?
And I discussed that kind of towards the end too. It's all in the lab instructions. Yeah.
I figured. All right, cool. Thanks.
Yeah, you're welcome. Great question. Cool. So let's use a utility called wget, which is this super common, powerful tool to just download data. I've linked the docs for, I think, all of these utilities that we're covering today. So if you're interested, feel free to kind of read up and see how others are using it. Even just like Googling wget data download, and you'll see some awesome use cases. But I guess part of this class, I think for me, is showing you some different tooling that's available outside of what you might have experienced in more traditional kind of Esri-based GIS courses. So I hope that this adds a little bit of value to your day. But yeah, let's use wget. And so we're downloading this data from ArcGIS online, I believe, and we're saving it into a local folder called Montana Fires. And I'm using a couple of like parameters on the wget utility, but you don't need to worry about that unless you're really interested. But we're just outputting the contents of this URL into Montana Fires. And now we're going to use DTRX to extract this Montana Fires dataset. The way that it's packaged from Esri is this like PPRX or like weird project directory, and it's kind of just compressed. And so we can still use the data inside of this ArcGIS Pro project, even if we're doing stuff with Python. So DTRX is just thinking and figuring out how to extract it, and it extracted to Montana Fires. We got some like warnings, but that's really just no biggie. There's probably a way to suppress that. It's just kind of letting us know our system information and kind of what the software was written with. So now we've extracted this data, and if you want a way to view this using kind of more of a user interface, you just click this folder icon here, and you'll see that we have this Montana Fires file, and then now we have this Montana Fires.1 directory. And so it automatically renames the extracted file to Montana Fires 1, I think that's kind of this issue with Google Colab not wanting same named items, but we're going to now use a couple utilities to move the Montana Fires 1, a nested folder inside of that, to this kind of root area so that it's just easier for us to work with. And then we're going to delete the stuff we don't want. And so if we kind of expand this Montana Fires folder and go into common data and raster data, this is the actual information we care about. Everything else is kind of like specific to ArcGIS Pro and things that I just don't really need, or you don't really need either. And so we're going to basically move the contents of raster data from this nested location to be like here at the same hierarchy as sample data or Montana Fires 1. So let's do that with the MV command, which I've also linked here. And so we're going to move this nested raster data to just a non-nested position. And so you see it didn't automatically update in the interface on the left just because you have to refresh it. And now you can see there's raster data here, which is pretty sweet. All right. And so we only really need this raster data folder. We don't need Montana Fires anymore, and we don't need Montana Fires 1. So I'm just going to use the RM utility to delete that stuff. Excuse me, Montana Fires is just a file, but the Montana Fires 1 is a directory. And because it has these nested subdirectories, I'm going to pass the -rf parameter, which is kind of like this recursive, it just delete all the nested folders inside a folder. So I'm going to run that. And then let's see what happens when I refresh this interface. Awesome. Now we just have this raster data. So imagine you don't necessarily want to use this kind of folder user interface display, or you just really want to quickly output the contents of a folder. We can use a utility called ls to just output that for us. And so ls really just lists the contents of a directory. And so here we're listing raster data, and you can see all the data that we saw on the user interface is there. Awesome. So this is kind of, now we're going to slowly ease into more Python-y things. This was really just downloading the data, extracting it, moving it to a more useful location, and then deleting the junk we don't care about anymore. So I feel like that's a pretty common workflow. You just might not be as familiar with it using command line instructions like MV and stuff like that. But these are like superpowers that I would recommend practicing. So for the remainder of this lab, we're going to be using a free and open source Python library called raster.io to kind of manipulate and create raster data. And so raster.io is pretty awesome because it gives you a way to use it from the command line and from Python scripts. And so we're going to cover both of those today. Predominantly the command line interface is for quicker things like checking information about a file, whereas you might use the Python interface for more complicated analytical things. But to start, we have to install some dependencies for raster.io and then raster.io itself. And so if you were working on your own computer, you would likely do this once and not have to do it again. When you're working in Google Collaboratory, these computers get wiped every like 4 hours or 5 hours or so. They don't delete like the code, it's more just the computer resets. And so you would likely have to reinstall stuff like DTRX or raster.io if you kind of save your work and come back a couple hours later. So that's just something to note. And if you run into issues with that, don't hesitate to reach out to me and I'll happily help you troubleshoot. But yeah, some of the dependencies that we're going to be using are a library called NumPy, which is for array mathematics in Python. If you think about imagery, they're just arrays of numbers. And so like stacks, multispectral imagery is just stacks of numerical data, which is just an array. GDAL is this super powerful open source GIS library that Raster.io is kind of using under the hood, and then libgdal.dev is kind of an extension to that. And then Raster.io, like I mentioned previously, is this raster image manipulation creation library for Python. And so this is just our computer letting us know that it's installing some Python libraries and just doing the work that we asked it to do. And it'll let us know when it's complete, but it's really just installing some packages, and now we're good to go with Raster.io. And just like that, we can start using the command line interface to Raster.io. They call it Rio. And so you can just check the version of Rio or Raster.io you have installed by running this command, rio-version. Awesome. So everything's working so far, which is really good. So one of the first things that we can do is kind of check information about our data that we've downloaded. And so to start, I will just display information about the 2020 or the 2014 data, which is before the fire. And so this isn't going to display anything like an image, but it's more like the image metadata, such as, I guess, the cell size, the checksum of the data, the descriptions of each band, which should look familiar, the data type, and just other miscellaneous metadata that might be of interest, and even kind of band statistics, which could be useful. And so sometimes you don't just want to display that information, but you want to save it and use it later. And so now we're going to do the same kind of Rio info command, but instead for the 2015 data. And then we're going to save it into a JSON file, which is something you should all be familiar with at this point. Maybe not total wizards, but at least have some exposure to creating and manipulating JSON. And so we're going to output that Raster.io response into a JSON file. And you can just use the caret here to output into a file. And so now, if we open this, you see that we have a G2015 JSON file here. I'm not going to open it, but yeah, it's really just the 2015 version of this output. Let me close this, and then we can actually inspect the contents of that JSON with Python. And so I've asked you previously to create and update JSON. You can also do that with Python and kind of automate some things. And so we're going to use the JSON library from Python, and then we're going to open that JSON file we just created and load it into memory. And so note that we're no longer using exclamation points, which indicates that we've switched from kind of more command line arguments to actually this is Python now. And so we're in Python land, which should be semi-familiar to most of you. So yeah, we're just using a pre-existing standard library to open our JSON file and load it into memory. And now let's display the keys in the JSON. So that's kind of like for lab 0, that would be like your name, your email, what you expect from the class. For this one, I expect the keys to be something like mask flags, interleave, indexes, height. It's all these values. And so we can access that programmatically as well. Awesome. And then we can actually kind of drill into a specific value, like descriptions, which lists all the band descriptions, which is great. And so part of your assignment is going to be calculating or determining the CRS of the 2015 imagery, which I kind of, if you need help, don't hesitate to reach out, but I believe I kind of provided enough breadcrumbs to get you going with creating that. So that's kind of one of your questions, so I don't want to give it away totally, but using some existing code cells, i.e. number 13, you should be able to mildly tweak and get the data that I'm asking you to get. And I'll be around here throughout the whole class if you want to do that in class or this week later and have issues or just questions. Okay, so let's move on to part B of the or no, not part B, just the rest of part 1. So let's import raster.io and some of the dependencies that we installed to help us do our data visualization and raster calculations. So we're going to import raster.io, we're going to import NumPy, some raster.io helper utilities for display, and then matplotlib pyplot, which is a plotting library used in a lot of kind of Python data science-y applications, especially in like publishing articles or visualizations for articles. Cool. And then let's load this data into raster.io. So you notice how I'm kind of pointing at this raster data 2014 and 2015 data sets separately. And I'm just going to load them into variables called data 14 and data 15 respectively. And then if you like, we can just display a random band in one of the data sets. So I've kind of pre-populated this with the 15 after fire data set and the third band. And so we can visualize our remote sensing imagery inside of Google Drive, which is kind of wild to say out loud. So you see how this data is kind of muddled and could benefit from some image enhancements. And so the Esri Learn Assessing Burn Imagery lab discusses approaches for enhancements such as contrast stretching. And so they have pre-built, Esri has pre-built kind of tooling available with their spatial analyst or imagery analyst extension stuff, but you can also kind of write your own. This is a really basic contrast stretching algorithm that stretches your data from the 5th to the 95th percentile. And so it kind of enhances differences present. So let's see that same third band with the contrast stretch applied. This is very much like a semi-basic contrast stretch, so I'd encourage researching alternatives, but just to give you an insight that it's really just some math happening behind the scenes, and you just gotta tweak it. And even in the Esri lab, they're not necessarily applying a global enhancement, and so this is more of an iterative exploratory process, to be honest. So we've displayed our data, applied a basic contrast stretch to kind of demonstrate that possibility, but let's get a little more into the nitty-gritty. When we're working with data across bands with different digital number values, it's good to normalize your values, especially for calculating indices. And so let's create a nice helper utility function that normalizes our data from the 0 to 1 scale. And because our imagery data is just a NumPy array, we can just use NumPy helper functions like the minimum and the maximum, which is super nice. All right, so now let's use our normalization helper utility and display a true color image. It might be a little ugly, but it's good practice. And so we're reading in the red, green, and blue layers. We're normalizing those layers and saving them to new variables. And then we're stacking those layers into this kind of new RGB variable and then just plotting that. And so you can notice that this image is kind of washed out, especially for RGB, but this is where something like a contrast stretch, some brightness, tinkering would really enhance what's being visualized. And so that's something that it'll be interesting to see if they discuss in the NBR articles, but we can talk about it next week. So we've manipulated some multispectral data for just display, but now let's actually calculate our normalized burn ratio data. And so we're going to do that using band 5 and band 7. And so I've kind of lazily created some variable names, band 514 to indicate the 2014 data, band 714 similarly. And so we read those into memory, we then normalize them, and then we apply the NBR formula, which is band 5 minus band 7 divided by band 5 plus band 7. And then we just display that data. Awesome. So this is before the fire. Now let's do the same calculation and visualization for after the fire. So you can see it's similar, but there's some differences. This area looks a little darker, like something happened here as compared to in this image. So I think that perhaps the NBR difference data will highlight that change. And so now we can take our NBR 15 and subtract the NBR 14 from it to create this NBR delta or change image. And then very similarly, let's plot that image. So you can see that it's still kind of washed out in a way, but there's these significant areas of red which are indicative of the burn area. And so the As We Learn lab discusses this concept of the standard deviation stretch, or they just mention it briefly, but you can replicate that in Python without any fancy user interface. You just kind of have to do some math. I found this super helpful function that was pre-written online. And so you're able to apply a standard deviation stretch. And so we're going to now apply a standard deviation stretch to our NBR difference data and then plot it again. And this should kind of highlight those areas of burn a little more effectively. And so you can see it's a bit more red. And let me replace that with the same color map just so it's not artificially more red. But you can see it's a little more highlighted than before what's going on in terms of burn damage in the area. And so kind of as we approach the end of part 1 of the lab, we're going to now display this data with a histogram as well. And so we're going to use matplotlib to kind of create a figure that has 2 subplots. One that displays the remotely sensed imagery, or the NBR index that we calculated, and then next to it will be a histogram. And so matplotlib is extremely powerful, and there's so many parameters that you can tweak. Even here, there's this ugly kind of legend that I didn't exclude, but we could have a whole course on visualizing with matplotlib in Python. And so I just wanted to give you a brief kind of overview of the things that are possible with this tooling. And then finally, we have our NBR delta TIFF. I guess it's not a TIFF yet, but we can take this array in memory and save it as a TIFF, and then we can use that later, which is super nice because you might not want to do your whole analysis in Google Colaboratory. You might want to continue in a software like Envy or ArcGIS Pro or whatever, even like R. So the ability to save your data is great. This lab doesn't require any of that, but I just wanted to show you that it's possible to save data that you create with Python. And then finally, let's list the contents of our directory. And you'll notice that in addition to the JSON that we created previously in our raster data, we have our NBR delta.tiff, which is great. And that's also visible when we open it in the UI. And so for the second question, I'd like you to use Rio, the command line interface to Raster IO, to display information about our NBR delta TIFF. And so you should be able to use previous cells that we've run to kind of be inspired to answer this. And if you run into any issues, I encourage you to reach out to your classmates and then me too, because I'm a resource. Yeah, that's it for part one in terms of Python. There really isn't too much that you have to create yourself. There's a couple where you're just kind of slightly modifying pre-existing code. And I think that it should be a fun challenge for you all. And then for part two, which I anticipate will take probably a few days, just because in my experience, I sometimes need to read an article twice for it to actually internalize in my brain. So I'm not saying you need to read these twice, but just for me, it sometimes helps. But yeah, just reading these two articles that are some of the more academic technical foundation for the normalized burn ratio. And so your deliverable for this part one and part two are slightly different. For part one, which is the Python lab that we went through today, I just want you to go through this code, running through the cells, answering the questions that I asked, and then saving this file, downloading it to your local computer, which I kind of save the steps here, and then uploading it to the GitHub repository I asked you to create last week. And so if you need help with any of those steps, don't hesitate to reach out, but I believe you should be empowered to upload the file. I think I shared all the necessary steps, but if there's any blockers that you reach, just let me know. So that's it for part one deliverable. For part two, I'd like you to write a 2 to 4 sentence summary. So don't just copy the abstract, but actually paraphrase the article in your own words for each of those two articles that I linked above. And then I want you to submit your response in JSON. So just trying to further reinforce this learning and kind of connecting the pieces. But I provided a template that you can very simply copy paste. So I encourage you to just like highlight this and copy this into that file and then edit with your information. So you won't be Alex and you'll have a different email, and then make sure to actually put in your description. And I've linked the articles, so you should not have problems accessing them, but let me know if you have issues. But once you create your JSON, I would really like you to open a branch in my repo and create a pull request with your JSON. And I've outlined the steps here, but it's really a matter of just kind of giving you some more exposure to GitHub and collaborative code on teams. And if you run into any issues, whether it's today or later this week, don't hesitate to reach out, whether it's in GitHub or via email. But yeah, I think that covers it in terms of the lab. I'm happy to answer any clarifying questions, but if you're ready, you can definitely get started. And that's about it.
Alex, question.
Yeah.
When do you think you'll have this video posted?
Sometime today. I mean, it's really just a matter of waiting for class to end and then uploading it to YouTube, and then I'll email you all.
Okay.
Yeah.
Yeah. I was trying to follow along, but I was having trouble seeing because of the pixelation of the screen.
Okay. Sorry about that. Yeah.
That's fine.
Yeah. The recording should be much better. But also in terms of the lab, there's like 2 lines where you need to add in like a word, but you don't need to like write Python from scratch or pretty much anything. You should just run these code cells and it should just work magically. So if anyone is feeling, not specific to you, Bruce, but if anyone's feeling kind of stressed, like if they had trouble seeing the stream today, like I'm sorry, but like I think that you should still be fine even without that. When you go through the lab, I think it should be pretty. It should just work.
Thank you.
Yeah, you're welcome.
When's the lab due? Due date?
Let me check when our next class is. It's basically before that. So just give me
Before
one
next
second.
class.
Yeah,
Got it.
I don't remember if we have class next week or not.
Next weekend. I'm actually gonna be out of town anyway if it's next weekend.
Yeah, this one's a little longer than last week, so don't feel like it needs to be done today.
Mhm.
But yeah, sorry, my Google calendar's doing me dirty. No, we have class next week. Yeah, so this is due next week. If you can't make it,
Next Saturday.
just make sure you submit it before class. So yeah, just before 9 a.m. on March 25th. This is due.
Sounds good.
Yeah.
Once you're feeling better, are we gonna go in person or is it we're just gonna Zoom it for the rest of the semester? Either way, it's cool.
From what I understood,
care.
this is gonna, or I didn't know this was online until last week, and then
Okay.
from
so
what
we're
I know,
Zooming.
it's fully online.
I'm down. I'm down.
Yeah. I'm game to like have a meetup, but I think it just works for people that it's online because it's convenient.
Yeah.
But like later in the semester, we should all definitely, if there's interest, like we can set up something and
For sure.
get dinner or something and just hang out. But yeah.
Yeah. Sounds good. But I'll email you. But yeah, next weekend I'm out of town, so
Yeah, just let me
I'll
know.
let you know.
And, no, yeah, it's fine. Yeah, that goes for anyone too. Like if you have some kind of pre-existing event and you know it's coming, let me know. And if something just comes up randomly because the world is chaotic, like I
Yeah.
understand. So just let me know and it'll be fine. Yeah.
Sounds good.
I wanted to ask a question too, Alex.
Yeah, go for it.
So I missed last week, and I tried to email you about getting the repo started, but when I tried sending it to your email, it said this account didn't exist.
Okay. Yeah. No, I don't know what's wrong with my like online credentials at Long Beach, but I saw your email this morning before class. I'm gonna get back to you after class. So,
Okay, thanks.
sorry about that. But yeah, it's like not streaming notifications to my normal email, and then it's just like weirdly blocking stuff too. I don't know, man. But yeah, sorry about that. This is my first time teaching at Long Beach, and so I think that a lot of the administrative things that have been set up for professors for years are not for me, and so I'm just constantly running into stuff that's like not actually configured yet. So apologies. I'm still waiting
Yeah,
on my
no
hiring
worries.
paperwork, to be honest, like the contract. So yeah,
Yeah,
good times.
it's tough.
Yeah, it's chill. It's fun, but yeah, it's fun work, so I can't complain. But yeah.
Alex, just to clarify, for part B of question 1, CRS stands for Coordinate Reference System?
Yes.
Okay, thanks.
Yeah. I guess this is a question for you all. Would you like me to stop the recording now, or do you want me to continue recording for the entire session? Because if I stop now, then I can technically start uploading it. What works better for you all? Because there might be questions that are valuable that come up. So I guess I don't want to necessarily cut that off, but I do want to give the option if there's consensus that just upload it now. So just putting that out there.
What's the consensus, y'all? Bruce, Iris.
I'm good for leaving it running because somebody's going to
Okay.
pop off with a great question.
Exactly. Yeah. It always happens as soon as you stop recording.
Yeah, exactly.
I think that's a good idea too.
Okay.
But then we should stop the recording for the good question.
Yeah, instantly. Oh, like, oh, sorry, my internet went out. Sorry. Oh, yeah. Yeah, I'm gonna go refill my coffee cup, so I will be back in a minute or so. But yeah, thank you all for putting work in, and you got this. Be right back. Someone stole the rest of my coffee. Rude.
Hey, Alex.
Yeah, what's up?
So we're using Google Colab to do this assignment, correct?
Yeah, at least like part 1, and then part 2 you'll just use like GitHub, if that makes sense.
Mhm.
So you might
Yeah.
want to go through
Yeah.
part 1
To
first,
answer the questions.
but I can, because I know you didn't do part 1 or lab 0 just because of the 10 or whatever, but you should still have access to the instructions, right? Or do you not?
For Lab 0 or?
Yeah, because I mean it kind of builds on lab 0, this lab a little
Oh, yeah, yeah. I was able to create a a repo on GitHub,
Okay,
but I
good.
didn't. Yeah, I wasn't able to I guess put in my information.
Okay, for sure. I'll follow up on the email after class. But yeah, um, I think once that's resolved, it should make sense. But I think it'll take you some time to submit at least part 2, just because you'll have to read the articles, and I don't know, it takes me a little. I can't speed read that like academic stuff. It takes me a little time. So I imagine it'll
Okay.
take. Yeah, I don't think you'll have to submit today. So I think you'll have some time before I respond. Yeah, or after I respond. Yeah.
All right, sweet. Thanks.
So Professor, not Professor, Alex. Um, I might hop off and do the homework and stuff, and maybe you'll still be here if we want to jump back on a little later.
Yeah, I'll be here until like 1. So
Okay.
whatever works better for
All
you.
right.
If you like quiet time, yeah, it's all good.
Yeah.
Around.
But thanks. And if we don't talk again, appreciate it. But maybe jump back on if we have any questions. But it seems like it's pretty straightforward. So.
Yeah. Yeah.
All right. All right. Thanks, Professor.
Yeah.
Ugh,
Honestly, it's all good.
whatever.
Yeah. Whatever. Have a good one.
All right. Bye, guys.
Hey, Alex,
Hey, what's up?
could you show us how to add a file in the repo? I'm in my repo, but I'm not able to navigate it very well.
Yeah. Let me show you. Give me 1 second.
Thank you.
So, do you see my repo on my screen, or is it like mad blurry?
It's a bit blurry, but I can tell.
Okay. So there should be a button that says code that's green, and to the left of it there should be a file, or like a button that says add file. And so if you click that and then you click upload files, this will give you the opportunity to select a local file. And so this
I
is
don't have the green button or like that second row of like, I have the top row where it says code issues pull request, but that second one with main, go to file, add file, I don't have that.
what repo. Could you share the link to your repo?
Share it to right here in the chat.
Yeah. Yeah.
I thought I did this in the lab one, but I might have done it wrong. Lab 0, I mean.
Okay, because it's empty. With the, yeah, this is because there's no README, I think. Yeah, when you created the repo, I'll show you what it is. I think that you just didn't select add a README. I don't remember if my instructions said that or not. So like, this is not a big deal, but I think that's why it's not showing. So we just got to add like some code or like a file, and then you should be able to add files.
Should I just redo it?
Potentially, yeah. And then, I mean, I've never actually seen that. That's so weird. This isn't like it's like not your fault. It's just like, yeah, GitHub's funky sometimes. But yeah, I'd say potentially recreate the repository, and then in the issue that you open, just link it again. And I guess you can use the same name. You know what I mean?
Okay.
Like you can delete your hello class 606 repo and then recreate it with the same name, and then the link will still be fine. But yeah, just when you make it, make sure to add a README, and then I think you should have that option.
Okay.
Yeah.
How do I delete? I don't see that as an option.
Here, let me show you. So you got to go to settings, and then scroll all the way to the bottom, and then it's literally the last option.
Oh, okay. Got it.
It's the danger zone.
Yeah. Okay. Thank you. I'll redo this. Thank you.
Yeah. Cool. You're welcome. But yeah, when you get to that step, if you still don't see it, just like unmute and we can figure out what's going on.
Hi, I have a random question.
Yeah.
I also wasn't here for last class, so I just wanted to see if there are any super important points that I may have missed. Also, would you not prefer us to call you professor? Is that something that you told us that I missed?
Yeah, I mean, so I don't know if I'm totally misreading. I'll answer your second question first, and then your first question. From my understanding, professors have, and so I don't have a PhD, and so that's why I'm just like, you guys can call me Alex or like Mr. Alex or Mr. Paka if that's more comfortable for you. But honestly, Alex works. I view you all more as like collaborators and contemporaries as opposed to that like professor student dynamic. And so I think that's also part of my hesitation, just because I view like we're kind of creating this together. Like I'll stop giving, I'm not going to get mad if you call me professor, but it's more just like, you can call me Alex and don't feel bad. I know that's kind of weird for some people, but I'm Alex in most of the time.
Okay.
Yeah. And then the second one, I saw your comment too, and I was going to respond to that, and then you unmuted, which is perfect. But I have like a course website where I've posted the previous like labs instructions, and that's where I'm going to update it, just because I'm trying to keep it separate from Canvas, because sometimes people lose access to Canvas, and I want this to be like a point of reference even after Long Beach enrollment might have ended. And so that's why I'm using GitHub predominantly, but I can post stuff to Canvas as well. But I'm going to share, I'm messaging you now the course kind of like web page where you'll have access to each week's kind of content. So I hope
Okay,
that kind of
thank you.
helps. Yeah. And so I'd say do lab 0 first. It should be pretty quick, but I'd say do lab 0 first and then do lab 1. Part 2 of lab 1 builds on lab 0 a little bit. And so you'll need to do that first, but it should be pretty fast. And I'm here to answer questions about either one. And I think that your students or your classmates should be able to help too.
Okay, I think I did do lab 1 or 0.
Okay, cool. Well, then
If
you're
I
good to
did
go.
it. Okay.
Yeah, I think it's great. Yeah, and like some other people are kind of doing, if you work better in a quiet space without stimuli, feel free to hop off. If you finish early or finish the kind of Python side of things and want to do the other stuff later, feel free to hop off. But I'm here until 1, so don't feel rushed. We got class time, so I'm here.
I have a question.
Yeah.
Will we be learning about like image classification or object detection
Yeah, I was gonna do that kind of maybe.
soon? Because that would really benefit my team and my project.
Yeah, no, that's super great feedback. Did you mention that in your response on the GitHub issue?
Something like that, yes.
Okay, great. I'm still kind of collating the feedback, but that's definitely going to be coming, I'd say, lab 2 to 3, if that makes sense.
Okay.
Yeah. I was thinking about doing some, I guess, a little bit more on spectral indices towards kind of more vegetation for next session. And then we have a week off, and then I was going to do something kind of more on the classification side of things. Yeah.
Okay, good to know.
Yeah. But yeah, any feedback like that is much appreciated, just to try to add as much value to you all as possible. So thanks for letting me know. And yeah, make sure you comment on the issue or respond to my comments so I can get more feedback too.
Alex, when we come to the part where we need to determine the coordinate reference system, are we just editing a line on this, whatever this is called, Yodel? I forgot, I don't know.
Yeah, so this is where here, I guess it's this. Can you see my screen?
Barely. Is that line 13? Okay, I see it.
Yeah, it's like the line below info 2015 descriptions. It's where the comment says determine the CRS. So use that line to, I guess, display information about the CRS. And so you can use something very similar to line 13, but replace descriptions with something else.
Check.
Yeah. So I hope that helps.
All right, thank you.
Yeah, you're welcome.
FYI, we got a taste of this up at the Cal GIS conference.
Oh, really?
Yeah, literally. This is the first time I was exposed to the Google Lab.
Oh, sick. Okay, cool.
Colab, is that what it's called?
Yeah, yeah, yeah.
Yeah, and but we spent all of our time trying to get our interface to work.
Like a local
But-
version of Python or
No, we're
Colab?
using R
Oh,
in
for sure.
Colab, and so it was tricky to configure.
Yeah.
However, this is fortunately for us, this is not the first time I've seen this,
That's good.
which
No.
is great.
Yeah, no, that's good. Yeah.
It's the second time I've seen this.
It's a little more straightforward with Python. You don't have to like configure as much.
Thanks.
Yeah, I know Collab has some like different ways or different languages you can use besides Python and R. But yeah, it might not be straightforward.
In question 1, part A, where are we supposed to answer that question?
Check. Yeah, so just do it like right below. So just do it. You see how I'm kind of double clicking? Just like put your answer here.
Oh,
Does that help?
thank you. Yeah.
Awesome. Yeah, and then just kind of do Shift Enter or whatever to like return back to the markdown.
Nice.
Yeah. I guess this is a good time to ask, what software do you all have access to? It seems like you had access to NV in the fall. Do you have access to any like Esri or other software like QGIS, or like what is the situation? Just because I've never, I guess the previous classes that I've been kind of affiliated with were always on site, and so the MS students were always in the lab. So I'm just curious how it is now that this is remote.
We do have access to Arc Pro.
Okay. Do you have online or any Esri?
No software like desktop. Oh, online, yeah. We have all access for Esri products.
Okay, good to know. Last semester, did you have about 1 to 2 weeks to complete a lab, or what was the approximate kind of turnaround time?
About 1 week
Okay,
usually.
cool.
I have a question.
What's up?
What's the purpose of normalizing data to scale 0 to 1?
Yeah, so sometimes I think it has to do with I think when you're comparing bands that can have different ranges, it can really skew results. And so, from what I've read, normalizing data to the 0 to 1 scale can kind of counteract that kind of effect. I'll try to find some resources on data normalization to share.
Oh, all right, thank you.
और ये कब तक है क्लास खत्म होने तक
Hi, Alex. I also have a question.
Yeah, what's up?
It's like very simple, but I just have like a hard time understanding this concept. Like install dependencies for Rasterio, then install Rasterio. Like what are like the dependencies kind of, I don't know. Can you explain
Yeah.
kind of further what that means?
Yeah, so in the context of like software, sometimes a software that you want to use needs other software to run. And so it doesn't automatically just lump everything together. It assumes that you have some stuff already installed. And so the dependencies are things that you just need on your computer already before Raster IO can kind of work as expected. And so it's kind of like almost like prerequisites,
So like,
you could think.
okay.
Yeah. I don't know if that's that helpful for you, but it's kind of just like support software you need for Raster IO to actually run as expected. So like with Esri software or Envy software, there's like things that your computer needs for it to run, like the operating system and just different utilities that you don't necessarily have to worry about, but different software is kind of packaged and shared differently. And so you kind of have to manage a little more of that in this scenario.
Okay, that helps. Thank you.
Cool. Yeah, you're welcome. Everyone doing good? Running into any blockers or just kind of plugging along? Just kind of doing a check-in. Cool. Thanks, Bruce. Like the thumbs up. Ali Khan also. Or Ali Khan. Thanks. Plucking along, cat. Cool.
Hi, Alex.
Hey, what's up?
So for the coordinate system, I've never seen this EPSG. Like, how does that differ from WGS84?
Let's Google it.
Yeah, that's a good, yeah, I should.
When in doubt, Google it. I don't actually remember. You know what I mean?
I'm just wondering, is it like a, I guess it's just a different,
So we just
diff-
84
I don't
UTM zone
know.
12 north. So it's just a specific like way to describe data. Yeah, I don't actually know what EPSG stands for. Let's try.
Is that common?
I've seen it before. I just it's just one of the ways to kind of describe. Yeah, I've definitely seen it used fairly commonly. What is?
Okay.
Yeah, I'm trying
That's
to figure
good
out
to
what
know.
it
I
is.
just haven't seen it.
I forgot what it stands for. Uh, Earth Petroleum Survey Group. Interesting. Okay. Yeah, I think it's kind of like a common interoperable way to describe projection stuff or datums and all that good information.
Yeah, thank you. I was just wondering because I hadn't come across it, but good to know.
Yeah. Maybe it's, I guess I might have had more exposure to it because I've done stuff with international data, and it seems like it might be more European international use. But
If you go into ArcGIS Pro and you select, say, for example, some feature class, if you go to the source, you click the layer properties and you go down to source,
yeah,
it'll show the projection of it. And under the WKID, it'll list the number and then it'll have the authority, which would coincide with the EPSG.
okay, for sure. Perfect. Okay.
Thanks, Bruce.
Yeah, thanks, dude.
Alex, can you explain question 2 again?
Yeah, let me take a look. Please use Rio to display information about the NBR delta TIFF dataset to your command line. Use the empty code cell below this question. Okay, cool. So I want you to use the Rio raster.io command line utility to
Okay.
display info about NBR delta TIFF. And so if we scroll back up, I guess I wasn't super clear, but that was a little intentional. But you can see we have this command Rio info that we can use to display information about a file. And so let's actually, like basically this command here where we're displaying things. And so
Gotcha.
I'm going to copy this and just scroll down to where question 2 is. And here, just make sure you update the data. And this should theoretically get you to where you need to go.
Gotcha.
Yeah.
I also have a question.
Yeah, what's up?
What is the difference between like installing Rasterio and importing it?
That's a great question. So, I mean, it's like the difference between downloading software and then opening it and using it. Kind of like where when we install raster.io, it's just on our computer, but it's not really like usable. It's kind of just there. And so when we're importing it into Python, then we're kind of letting our computer know to like load it into our active toolbox. I don't know if you have a ton of experience with like Esri products where you have to maybe turn on a certain license, but it's kind of that similar where you're like importing a feature set that isn't the standard whatever. Because like if you think about Python isn't really made specifically for remote sensing analysis. And so we're importing this raster.io library into our Python kind of workspace. And does that help? And let me know,
Yeah,
be honest if it doesn't.
We don't have to actually install it on our computer, right?
No, that's why I'm using this Google Collaboratory, because it's installing on Google's computers that you're just kind of using temporarily, and so we're not having
But
to
how come
edit
you got
anything
kitty cats and crabs and dogs walking across your screen?
because I'm awesome that way. I mean, I'll show you how
Yeah,
to do
but
it.
how did you do it?
Go to Tools,
Yeah.
Settings, and then go to Miscellaneous. And then this is where you can turn on corgi mode, kitty mode, and crab mode. And then one mode that I didn't have that is kind of aggressive but funny is the power level. So I'll show you what that does. Like, watch this. This is intense.
Oh.
It's like too much, but yeah, like it's kind of silly, but I dig it. You can have a little fun when you're working. You can change the setting to be dark or light or whatever. There's different. You can connect your GitHub account, which I have done, and it's very convenient for doing kind of quick analyses as necessary. But yeah, I'd say explore the settings. But yeah,
It's not working. Oh wait, there's a kitty cat.
yeah, it might just take a second to like start. But yeah. And it's nice because throughout the holidays they have different like ones. I remember in Halloween they had ones with like witch hats and stuff, and I think that they have just different themed cats and stuff. So it's cool. Not what I was expecting from a Google experience. You know what I mean? Something kind of cute and silly.
I mean, Google Doodles are always like that.
True.
So number 14, we have to do that ourselves, right?
Yeah.
Determine the CRS of 2015 imagery. Is there CRS? Okay, I got it.
Yeah. And if you run into issues, just let me know, and I'm happy to show you how to do it.
So 2015. Okay, I think I got it.
Heck yeah. That's always a nice feeling. I think I got it. So yeah.
What are the band names for 2015 imagery data? Double click the cell and write your answer below.
Alex, does if we're working in one directory, do we need to input something from our previous question, like changing directory in the code?
Could you be a little more specific on where in the code you're talking about?
Oh, okay. Say, for example, on question, where's it at?
Like question 2 or whatever.
Yeah, question 2. The question is, display the information. Now, when we input, we pull the example from the previous one up above. It's in the raster data directory.
Yeah.
However, the NBR delta is in the sample data directory. So do we have to change directories?
So actually, if you
or
notice,
just listed in the code?
Yeah, so if you notice, the NBR delta is not in the sample data directory.
Oh, it's not. You're right. It is in the root.
Yeah. So try it without any preceding folder and let me know if it works.
Check.
Yeah.
Perf. Thank you.
Yeah, no worries. It's always something like that, you know, just like some weird path that's slightly wrong or just like, that's what I've noticed in my experience. It's just like
code drives me crazy. I'll never be a coder because I'll pull my hair out because I didn't see the colon missing.
Totally. That's why I like to show people more like command line stuff, because you have a lot of the issues of coding, but it's just less. It's like a single line and like you're just kind of doing an operation. And I don't know, you can do a lot of powerful things quicker than in a user interface kind of scenario. So there's pros and cons for sure.
All right. Yeah, that was it. Thank you.
Awesome. Great.
Okay, so part B is something we already did. Since I did the CRS before reading part B.
Yeah, that's cool. So just honestly paste the information just below part B. You know what I mean? Like,
okay.
Yeah. Sorry, that wasn't as clear, but yeah, as long as you do that cell and you display it there, and then it'd be nice if you also pasted it below part B, but as long as I can see it there, you're fine.
How do you make new lines in the
Yeah. So you see here, there's like a button that says code.
No, not like the new code lines like in question 1.
Oh, here. So double click on the cell.
And how do I make a new line once I'm in there?
Just do like enter.
Because it just is like, I put it on like a new line after the thing, but it's like stuck in a paragraph.
Can you open it and just do it like a line above part B like this? Like write it here. Do you see what I'm doing here?
Well, then it's gonna get stuck into the it's gonna be put in the
Oh, the bullet or
The
whatever.
yeah, the bullet with the rest of my
Add
other
it.
ones.
Add
It's
a
below
number.
part B. It's at the very end.
Oh, you mean here?
One?
Like here?
Yeah.
Just do a
But like,
line
yeah, I
between
put it right there and it's like still in a paragraph.
Does it look like that when you do it? Can you see?
No, mine's like after the period.
Can you do a couple new lines? Like just press enter a few times to see if that helps.
I've pressed enter about, okay, now it's moved. I don't know why I was doing that.
It's yeah, it's weird
Okay.
sometimes. So yeah, no worries.
The matplotlib
Yeah.
image is like just black. That's okay, right? There's like a tiny amount of stuff.
Can you? Which one are you? What line are you on? Or like what commands are you
I'm
running?
on the line load RGB data, normalize and display.
Yeah, no, it's like mostly black. Yeah, yeah, it's kind of messed up. Yeah, it just needs to be like stretched and enhanced, but we're not worrying about that too much today. But yeah, it should be good if it's like mostly dark. Do you all know Scott Winslow?
Yes.
Okay, for sure. Has he taught you all, or oh yeah, he did the UAV thing. Okay. Yeah.
Where did we want?
And then there were 3 or 4, I guess, including me.
I'm kind of confused about the Rio thing.
Yeah. Which you mean like the last question 2?
Yeah, like there's the JSON, then
Excuse me.
the raster. Oh, and BR delta tiff. Do I have to do it where before I think we saved the JSON is like info 2015?
Yeah, you're like so close. Exactly. We don't need to save the JSON, but it's that that same command that you're thinking of. This one.
So like with open as F.
No. So that's only if you're doing Python, but we're just using Rio. So you can literally kind of copy paste this line and then just change the name of the file. So in this line here, we're looking at the file 2014 inside of raster data, but I'm just asking you to display info for NBR delta. So you should be able to tweak this slightly and then get what you're looking for. But let me know if you kind of are still blocked.
All right, real info raster data.
Alex, can I grab you real quick?
Yeah, no, I'm here.
After we download our file and we click upload, I noticed you were talking to Olga. Are you saying go to add file, upload files?
Let me navigate there real quick. So it should just be add file, upload file.
And that's it.
Yeah, and then you just select
It says
whatever.
it says uploads are disabled.
Are you on your directory? Or your repo or my repo?
Well, I'm in Alex, I'm in yours. Should I be somewhere else?
Yeah, you should be in yours. I think I say in the instructions to do it in yours. And that could be why the uploads are disabled.
Okay, I don't have any kind of interface that looks like yours whatsoever.
What does yours look
You
like?
just have to hit make a copy.
Well, you're a smarty pants because I don't know how to do that.
Oh, I took hydrology and we did a bunch of that. And we did a bunch of collabs, so.
What do you mean by your interface is different than mine?
Can I share my screen?
Yeah, or you can even share the link to your GitHub and
Sure.
I can display it too.
Got it.
That way others who are watching can see. All right, give me a second. Okay, yeah, so this is the same thing that Olga had. I would say this is because when you created the repository, you didn't select the add readme option. And I don't honestly remember if I included that in the instructions. So this is not like anything of your fault. It's more just, I'd say the easiest option is to delete this repository and then recreate it with the correct option and use the same name. And I can show you how to do that too.
Yeah, if you don't mind.
Yeah. And so I don't have the option because it's not my repo, but you should have something that says settings and it might be hidden behind this 3.
I see the settings.
So click settings on your repo and then scroll to the
down
absolute bottom and then click delete this repo.
Okay. Expect bad things to happen if you don't read this. Got it. Very whimsical. I understand the consequences. All right, done.
And so now go back to your, and like, I guess on your interface, it should be toward the top right, but do the new repository thing. Click
New repository.
Yeah. And then rename or name this repo the same thing that you just deleted. So GISC 606. And then when you do the initialize the repo, make sure you select add a readme. And then you're good.
Create repository.
Yeah. And then it should have.
Hey, look at that. Now there's an add file. Upload
Beautiful.
files.
Beautiful. Yeah. Okay. So just now you should be good to go.
Now, do you want us to add any comments or anything to that, or you get it?
So for part 1, you just need to upload your notebook, basically like the thing that you did today, and then follow this up creating a branch that's part 2. Part 1 is just uploading it and then paste paste the link of the file in that GitHub issue.
I did.
You did
commit changes.
Excuse me. Yeah, so upload it. Yeah, commit. And so now you should have a file. Yeah, perfect. I see there. And then I want you to copy the link for this file. So like .com null island is life, blah, 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 like this URL, and paste it into the issue.
Are you talking about the address bar? Grab the entire link,
just the
or
whole
just
address bar.
right click that particular file?
Nah, just right click the address bar. I mean, it'll give you do the same thing. If you do copy link or so it'll be just the URL and then go to choose where you opened it. So I don't remember if you said Bruce or your pseudonym, but just paste it in whichever one is yours. Oh, Bruce Williams. Yeah.
Okay. What?
You're
Are
Bruce
we
Willis.
doing this in yours or in mine?
So it's kind of both. I want you to save it in yours, and then I want you
Which
to
I just did.
Yeah, so you're done with that. And now I want you to take that link and post a comment here.
Under issues.
Yeah, in the one that you opened already. So like you and
Here,
I have a conversation going in that issue, sort of. So if you can
I
just
think.
post there. So on my screen, so you can see like posted here.
I see there's, okay, if I go to your username and your repository, I see my name listed there.
Yeah. So you want to visit this link that I'm sharing in chat. Whatever the issue you created, issue 19. And so this is where
Okay.
you'll, below my most recent comment, post your response. Also, respond to my comment when you get a chance to, so I can learn more about your project. But yeah,
All right. Did
you're,
you
you're done
see
with
that?
part 1. Yeah, I see it.
Oh, thank God. All right.
It's
I
not that
wasn't
hard. Yeah.
aware of, that's okay. I wasn't aware of this comment.
For sure.
I did, should I get notifications that you commented?
It should, and if it's not, let me know, and I can help you.
You know what? Let me check my email real quick.
Yeah, you're officially done with part 1, and then now you just gotta do part
because
2.
I created this email for this class.
For sure.
And I have not gotten in the habit of checking it yet.
Yeah, I feel you. But yeah, that's it for part 1. So you're good to go, and then the rest is just kind of reading those articles and then kind of summarizing them very briefly, and then posting the response.
All right. Let's see. Hey, issue, thanks for. Okay, yes, you did comment. All right, I'll get in the habit of reading this email inbox.
Okay, cool. Yeah, and
all
always,
right. All right.
Yeah, that's it. Thanks
all right,
for
appreciate it.
up.
Thank you for your time.
Yeah, no, thank you, man. Have a good one.
You too.
Y'all are both doing good. Anything I can do to support you or help with whatever, or is he kind of just plugging away?
I'm just really slow at coding, sorry.
No, you don't have to apologize. No, this isn't, I'm not like mad at all. I'm just wondering if there's anything I can do to help. But if not, then
Oh,
just
I
keep
was
working.
waiting for you to finish with Bruce because
Okay, for sure.
I got a traceback error.
Oh, okay.
And I can't find the file.
What
even though it's the nbrdelta.tif and I copied it.
Could you paste the command that you're running in chat?
No, because I'm on my phone on Zoom and it's on my computer.
Can you
I did exclamation point Rio info raster date underscore data slash NBR underscore delta dot TIFF dash dash indent 2 dash dash verbose.
Okay.
It was exactly the way you did it in the other one. And then I changed it so it was the NBR data dot TIFF. It's under a different directory?
Yeah, so that's why you're not getting the
I don't know how to find that because it's not like my computer.
Yeah.
I don't know how to find the directory.
So
like ls?
Yeah. So
or what?
one thing you can do is just exclamation point ls and it'll tell you what's here. And so you can see we have the JSON.
Exclamation point ls, the directory contents. I ran that earlier on and it just says G underscore 2015.
Yeah.
NBR delta, raster data, sample data.
So can you see my screen, by the way?
Yes.
Okay. So the reason why it wasn't working is because raster data doesn't actually have a file called NBR delta. If we do ls raster data, you can see that, there's no, raster data. There's no file called NBR delta in here. But if we look in the current directory that we're in, you do see that there is a raster or NBR delta TIFF. And so if we update the Rio command and remove the raster data folder, we can just point directly to NBR delta TIFF.
Okay, I found it.
And then you should be able to run and get the response or the result as expected.
Okay, assigned readings. Oh, it's 2, okay. Save copy to your notebook. in the GitHub repository. GitHub repository. How do I save it into GitHub?
Yeah. So did you download it already to your computer?
Oh no. Oh,
Okay.
click file, download.
Yeah. So once you've downloaded the file, if you go
Not a .py, a .ipy.
Yeah, IPYNB. Yeah, exactly. And so when you go to your repo, the one you created, you should have an option to add file and then upload files, which I'm showing on my screen currently. And if you don't, let me know and we can troubleshoot.
New project. Oh wait, this is V1. New view. The repository. It's under the import code, right? Or
It should be under add file. Is your repo empty? Do you have a different view than mine? If you yeah, if you wouldn't mind, could you share a link to your repository in chat? Or I guess you can't. But what is your username? And then I can just search for it.
my is Holden F.
Holden F.
I have one issue because I was confused during lab 0 and first made the issue in my
Yeah, it doesn't seem like you have a repo.
Oh, underscore. That's not me.
Oh, okay.
It's my face.
Is it all like lowercase?
Uppercase Holden and uppercase F or dash. It's not an underscore.
Okay, cool. Yeah. Okay, perfect. So this is the issue that happened to others too. I think I just didn't include this in the instructions last week. So we just need you to delete this repo and recreate it, and then make sure you add a file when you're creating it. And I'll show you how to do that really quickly. So on your
the README?
Yeah, and I'll show you how to do that. We just need to recreate. We're going to delete this repo and then recreate it with the same name.
Oh, I mean, under the code thing, it gives me an option to make a README right now.
Okay, then do that. Yeah, just do a quick one. It can have anything, and then we'll just add stuff from there. So yeah, just add like a basic README. It can just be like placeholder text or whatever. It doesn't have to say anything important.
Pro tip type G or P. And it was giving me the option to import code.
You don't have to do that yet, but as long as you just create the README, it should be fine, I think.
Ugh. Create a new repository on the command line. Quick setup if you've done this kind of thing before. Get started by creating a new file or uploading an existing file. We recommend every repository include a README license and blah, blah, blah. Okay. Mine's uploaded now. I didn't need to add a README.
It is not displaying for
I
me
should though.
yet. Okay, might just take a second. Yeah.
I haven't hit commit changes yet. Do I need to?
Yeah, you might have to commit the changes in. Are you doing this on the command line or the user interface?
The user interface.
Yeah, then commit changes. Yeah. I don't think it'll display until you do.
Oh wait, I'm supposed to like, what's part 2?
That's to be done basically after class. You have to kind of read 2 articles and then just do short summaries on them and kind of post your response. And it's due like before next class.
But that's different from uploading this.
Yeah. It's the second part. Yeah.
It says lab 0, but this is lab 1, right?
Yeah, this is lab 1.
It says like save a copy of your notebook in a GitHub repository you say created during lab 0. Oh, wait, we already created that
Yeah,
repository.
the repo created during lab 0. Yeah. 'Cause I don't see the file that you're uploading. It's not showing on my.
I haven't hit commit changes because I want to put, it says add an optional extended description. And I haven't,
Where?
I don't know if I should put something in there.
Oh, you don't have to. That's just like GitHub. Yeah, you don't have to worry about that.
Okay, it's in there now. Help people interested in this repository understand your
Perfect.
project by adding a README. Add README.
Okay, yeah, I see your lab now. And so to finish your submission for lab 1, you just need to post a comment in my repo with the link.
In the JSON format?
No, so this is still for part 1. And so for part 1, I'm asking you to paste the link to your IPYNB file in the GitHub issue that you opened last week. So for you, that would be my
Okay, I think I found it.
Yeah, it's that
And
repo
then,
that I have. So just post a link to it there.
How do I get back to your repo? Oh, wait.
I'll share the link in chat. Or no, you can't access it.
I found it. Yeah, I got it.
But yeah, just comment on your issue and paste the
How
link.
do I find that?
Yours is Holden Ford Lab 0. It's issue number 14.
Oh, issues. There we go.
Yeah. And then part 2 instructions, it's really, I tried to lay it out pretty clearly in the lab instructions for submission, but if you run into issues, don't hesitate to reach out. But it's kind of just like formatting some JSON and then opening a pull request to submit it and stuff like that.
It's already in JSON, right?
Yeah, you need to update the values to like your own. Because if you look at it, it says like Alex Pakolnishkas and my email. And so like update it with your data and then your actual summaries as well. And yeah, you have until
Merge
like
changes into a main branch by opening a pull request. Type your branch.
But I'd say maybe wait to do that until you finish reading the articles because you need to submit the summaries as part of that.
Okay.
Yeah, that's the lab basically. How's it going, Ryan? Doing okay?
For now.
Cool.
Yeah. What's the best way to get a hold of you during the week?
Either email or GitHub issue, like the one you opened in my repo. If you just comment there, I'll get back to you there too. So whichever you prefer, to be honest.
Okay. Well, I guess I'm good then.
Okay. Yeah. If you have any questions, just reach out. I'm available.
Thank you.
Yeah, you're welcome. How's it going, Holden? Are you just kind of reading now, or are you still working on the lab? Or are you just chilling?
My cat arrived. But I am about to start the readings.
Oh, cool.
It was just she was being annoying and not just meowing at me instead of jumping up.
Harassing you.
Yeah. Right. So in the other coding class, we were supposed to use PyCharm. And for for some of the assignments, I was able to use, because before we were using what is it?
VS Code, probably.
Like the Anaconda.
Okay, yeah, for sure.
We were using Anaconda to use Spider. And I like the Spider layout because I can't really figure out how to use the PyCharm Community Edition. I don't know. It's really confusing to me. And I got really kind of embarrassed because we were supposed to be able to import like ArcP into it, or so that we can run stuff and make stuff in ArcGIS through PyCharm. But I couldn't figure out how PyCharm works, so I haven't done any of those assignments yet. He gives us until the end of the semester to turn them in. But
Oh,
I'm
for
like,
sure.
fuck.
Yeah, I don't have experience with PyCharm, but I could see why it could be annoying. I've mostly used VS Code and then also like Anaconda, Jupyter stuff. But yeah, if you could like
Because I
bring
was
stuff.
looking it up, and you can't really use. Well, it's just also like the layout of PyCharm I don't like as much as Spider.
Yeah, I don't know if you're able to like
And
change things in PyCharm to like change the UI.
and then you can't, like, I looked it up and it's really weird. They like, you can't really get ArcPy in Spider for some reason. I tried and then it just wasn't working, and there was like a million issues that were really hard to understand.
Yeah, I'd say it might be worth it to try either using Anaconda again or like VS Code.
Can you do Python coding in VS Code?
Oh yeah, I do all of my Python in VS Code.
And how hard is it to get the stuff
I just shared a link.
in, like, how do you get the how do you get ArcPy into it? Because like you have to do something where like you change the environment or something.
Yeah, I don't actually use ArcPy, but like you can configure it. I shared a link in chat where they show how to set up ArcGIS Python with VS Code. So I'd say try this, and then if you still run into issues, let me know. I don't use, like, at my work at Esri, I don't actually use Esri software or like do GIS. You know what I mean? I'm like building software for to facilitate that stuff. But I'd say that in my experience, VS Code is a little more plug and play. So I'd say try that. Yeah. Hey, Kat, what's up?
Hey, I had a question. When I am answering question 2,
Yeah.
what I'm using is not working correctly, and I'm trying to figure out why.
Yeah.
Should I copy and paste it or like share or
Yeah.
something?
Yeah. Copy paste the command that you did in the screen or into chat.
Okay.
Yeah. Okay, great. So if you notice, your command has raster data / NBR delta TIFF. But if you look at the raster data folder, there's not actually a file in there called NBR delta TIFF. And so that's the issue that you're running into. You're just pointing to a file that doesn't exist. But the NBR delta file does exist. It just doesn't exist inside raster data. And so if you look at my screen, you'll see that it's kind of one folder level above. And then the line directly below where I've highlighted, you'll see how I've kind of invoked Rio to display info about that file. You can just delete raster data / and then you should be good to go.
Okay, thank you. That
Hey, you're
seems
welcome.
silly. Thank.
It's all good. Hey, Holden, are you still working on the lab or are you in the reading phase now? Just in terms of the recording, if I can stop it.
Wait, you were still recording?
Yeah, I've been recording this whole time.
Can you delete the part where I was talking about not finishing all the Python? I don't want people to know that.
I might forget, to be honest, just because it's like already 2.5 hours, the recording. But
It's like cutting off the last like 10 minutes or less.
I'll
Yeah,
I'll
I'm
try.
not working on the lab anymore. I'm in the reading phase.
Okay, cool. Well, I'm gonna stop recording then.